Okay, so we'll have a look at nmap for doing some network sweeping first of all. So if we have a look at the nmap help, it's pretty wide ranging. So if you have a look at the man page, there's absolutely stacks of stuff in there. So I'm using Control F to go forward a page and Control B to go back a page. And we can do searching with slash. So if we want to search for host discovery, for example, we could search for slash. We could search again and again. We can go back with question mark. So good to get a few of these types of things maybe noted down, so you can use the man pages of the various tools, and Q or colon Q to quit out of the man command itself. So this is the man command, and this is actually the parameter you're giving it, which is the command you're interested in looking at the manual page for. Okay, so there seems to be a little bit of confusion over that at points. So the help is again quite extensive, but it's quite useful. It's split into little groups and it's not quite as large as the man page. So again, the thing to do there is to pipe that into something like less, and again we can use our Control F to go forward, Control B to go backwards. So yeah, we can use our Control F and our Control B to go forward and back. So here's our target specification, and here's the parameters and flags that are to do with that type of scanning. So our host discovery or our network sweeping is what we're going to do first. So this is the section which is concerns that. Our scan types are for port scanning. We've got version detection, which is our fingerprinting of the services. We have scripts, which we'll look at in a future lab. And we've got OS detection, so we're looking to try and fingerprint the operating systems of some targets. We can also do things like change the timings, so we can do fast and slow scanning with T 0 to 5, and we can also do, I think there are some other options as well where we can adjust the timings. So these are for IDS and firewall evasion, and output parameters where we can save to different formats, and we can do things like packet trace. So let's copy that because we're going to use that one first. So these are the various different things. So this is your verbose output, debugging output, and packet trace output, which we talked about in the lecture. So there's many more things than what we discussed in the lecture, but we tried to cover some of the most useful. So here's some examples where they're using verbose all the time for the output. This one's an aggressive scan, which is going to do an operating system fingerprint and version fingerprinting and all sorts. This one is a host sweep, so it's actually going to do 2 network ranges specified here. And this is not going to do port scanning, it's just going to do a host sweep. So that's what we're going to look at first, host sweeping, network sweeping. And the man page has got the full help. So if we can Control Q out of that. So perhaps what we'll do to start with is, we always use verbose, we use -n so we don't do DNS lookups. And what we'll do is we'll scan our target, which we happen to know is already there, and we'll have a quick analyze of the packets that nmap's generating to do this host sweep. So it's -SN means it's not going to do port scanning, it's just going to do host sweeping. So it's basically just host discovery, checking if the host is up, or pinging the host basically with some packets. So if we pull up our TCP dump for this particular, so So our local address is this one, and our gateway is 94, and this is the network we're directly connected to, so it's a /29 network starting at 88. So we're going to be talking 89, which is our address, through to 94, I think. So if we are TCP dump, so we're going to do no resolution, we're going to do verbose, and we're going to look on the interface, and we're only going to filter, we're going to filter out the packets going to and coming from our host interface, which is that's the correct interface. So we'll let that one go, and what we'll do is we shall scan the host on a different subnet, which we know is there, which we've already found, and we shall use our packet trace flag. Okay, so what packet trace does is it actually gives us all of this extra information which you would not normally get, which basically tells us the type of packets it's sending to the target. So in this case, it's sending the 4 standard packets, which it does for host discovery. So if we send this across an entire network, it would send these 4 packets to every host to check if the host's up. So we're talking about a echo request type 8, code 0 ICMP packet, a TCP packet, a SYN TCP to 443, an ACK TCP to port 80, so looking to see if a web server is running, which is quite common, a ICMP timestamp request packet, which is a 13, and this is the packet that's come back from the target to show that the target is up, and this is us reporting that that target is in fact up, which we did already know. Okay, and our TCP dump output should confirm what's actually being sent, because this is just nmap telling us what it's sending based on this packet trace flag. So this should tell us we are sending out an ICMP echo request, which is right. We are sending out, no, sorry, we're getting back an echo reply, which is great. That confirms what we already saw. That's our SYN going out to 443. I'm looking for our ACK. Where's our ACK? That's our packet coming back from 443. That's our reset to 443. There's our ACK. So that's our ACK there, going to 80. That's our reset coming back, which means it's not there. That's our timestamp. So that's basically the same packets. So those 4 packets are sent out as part of the host discovery for a different network than the one we're connected to. So using ICMP. So if we run this on our local network, and as we saw, this is our local network here. So 94 is our gateway, 89 is our, this is the network address, 89 is our host, so we're talking about 90 to 94. So we can run it across a range of addresses, and this should give us slightly different results. So it's saying there aren't any hosts up at these addresses, but we can see correctly that our gateway host is up at 94. And interestingly, if we look at our TCP dump output, we can see it's not used the standard 4 packets including ICMP, but it's been clever and it's used broadcast ARP packets instead. So these are who has packets to the hosts we're looking for. Because it's a directly connected network, it's decided to use ARP, which is going to be a little bit quicker. So that shows you the difference between nmap scanning on a local network and scanning on a remote network by default. Now we can also choose to send out different packets. So if we go back to our original, we can choose to send out individual ping packets. We can send just ICMP. We can send individual echoes. We can set timestamps, net mask requests, and various other things. So we can also send our port scanning type packets to specific ports just to do pings with TCP also. And as we discussed in the lecture, we can do various ranges. So let's just try an individual timestamp request packet and see if that works. There we go, so it's reporting that the host is up, so we must have got a timestamp back. And if we look at our TCP output, we can see an address mask request, and we've actually sent one out and we've got an answer back. So it gives you an indication of some of your individual flags you can set to do very fine-grained host detection depending on the scenario. So we can also use nmap to do trace routing. So we can do minus trace route. Let's just do the host that we know is up. Again, the same. Oops, it's going to be doing port scanning. So what I wanted to do is just tell it not to do port scanning. So the same flag as our host discovery. So we don't port scan the machine on the 1000 ports by default. So there we go. So it's very quick without the port scanning. And it's found one intermediate device, which is our local gateway device, which is correct. And if we have a look at the way it's done it, it's quite interesting. So as opposed to traceroute, which you'll do in the lab, it actually does the TTLs back to front. So it increases its TTL until it finds the TTL of the target, and then it reduces them, and it actually does some other things too. But it's an interesting way of doing it, and it uses ICMP as opposed to the UDP of the standard traceroute under Linux. So you can have a look at that too.